in this section of maths we're going to look at further calculus. That involves differentiating and integrating complex functions like the ones below. Here we have a function with a bracket and a power, which you haven't seen before. We need to differentiate and integrate these things. And also we need to do integration and differentiation to trigonometric expressions involving sine and cos. We will learn how to do this in this topic. So first of all, if we look at the sine wave, we're going to look at how to differentiate sine. So the derivative of the sine function, or the sine wave, is easiest explained by drawing the graph of the derivative. So if we draw the graph of the derivative of sine x, then any stationary points that you see have a gradient of 0, because the graph of the derivative is really a graph about the gradient. So the stationary points will go down to 0 on the graph of the derivative, which is over here, and you'll see the stationary points there and there. These are that stationary point going down and that going up. The next thing you look at is this part of the gradient in the sine wave is positive. So you can see over here we've got a line that is positive, i.e. above the x-axis. When we go after the stationary point, we've got a negative gradient, so after the stationary point you can see the gradient dips below 0. And then here we're still in a negative gradient, so we're in a negative gradient over here. After this stationary point, which is that one there, we get a positive gradient up to 2 pi. So that's why we've gone above the x-axis here. So in the graph of the derivative, really we've created a new wave. But if you look at this closely, you can see it's just a cosine wave. This here is 90 degrees, if you like. That's 180, 270 and then 360. So what we can see is that if we have y is equal to sine x, then dy by dx is equal to cos x. Now, a quick look at the differentiation of cos x, we can do the same thing. We can look at the stationary points and we can put them down to 0 on the graph of the derivative. You'll see that happening here and also here, going down to 0 at the end, and also here, going up. Now, between these two values here on the cos wave, we have a negative gradient, so we'll start off going down the way, going under the x-axis. We're still negative up to pi, so in this, the graph of the derivative, we're still negative up to pi. After pi, and all the way to 2 pi, you're in a positive gradient, it's going uphill, all the way here. So we can say that after here, pi we're positive, and then back to 2 pi we're still positive. Now this graph is very like the sine wave, but it's upside down, so it's really negative sine x. And what we can say is that when we differentiate cos, you get negative sine x. Or sometimes you see it like this, d by dx of cos x is equal to negative sine x. Both this formula and the previous one in the last screen will be in a formula sheet.